Hey guys, welcome back to Weld.com. Stop, I need to give that dude a shout out because he sent us Hey guys, welcome back to Weld.com. So today we have another viewer requested video. A friend of mine or an acquaintance through Instagram, Rippy154, also known as Stephen Marshall, asked if we would do a 1-inch plate test because he wants to see some side bending. Typically side bending is going to be done with 1-inch plate, although it can be done in 3/8 as well. So this plate is very similar to, or it's actually the exact same thing that I did when I had to get my certifications for ironwork. We had to perform a 1-inch test, 3G and 4G. So some of the specs of this test: we have a 1/4-inch root opening. Both plates are beveled at 22.5 degrees for a 45-degree included angle. That means the entire opening of this angle is 45 degrees. The plates are 6 inches long. According to D1.5, they have to be 5 1/4. D1.1 minimum of 5 inches. So by having these 6 inches long, we're satisfying the requirements of both. The only tools that I'm going to be using on this for cleanup, once I start the weld process, is the chipping hammer and a wire brush. I'm not allowed to use any grinding attachments, no power wheels, no chiseling, no filing, none of that. So just chipping hammer, wire brush for Interpass cleaning, and I can't remove or reshape the weld profile with any other tools. So it's a weld test, so that's what we're gonna do. We're gonna weld, it's not a grinding test. One thing I do wanna note is take careful consideration when you're doing all your prep work. I've already removed all the mill scale from the areas where I'm gonna be welding front and back, as well as the backing strip. And then I went ahead and took a flapper wheel and just kind of polished that up just a little bit more, makes it a little bit smoother. I have a knife edge in here, so there's no land whatsoever on the bevel. I have run-on and run-off tabs. The run-on and run-off tab is just an extension of the backing bar. So I have about 1.5 inches on the bottom, 1.5 inches on the top. So right here I have additional run-on tabs, and these are just on the face of the bevel. And what that's going to allow me to do is maintain that same bead height. So once I get to my cap, I'm not low at the end here, because everything has to be flush to 3/16 on a 1-inch plate. I'm allowed to go up to a 3/16 weld reinforcement, whereas with a 3/8 plate we're allowed 1/8 inch. With the 1-inch plate I can have up to 3/16. So I want to make sure I have proper fill, so I don't want these corners or these edges here to dip in. So I want to make sure I'll be able to fill those up. So I've just installed these little run-on tabs here, or run-off tabs at the top, and it's just no more than a 1/4-inch plate just tack welded in there, and it just runs parallel with the bevel face. All the way from the prep work, I'm starting to plan the foundation for that final cap. Stack the deck in your favor and set yourself up for success. So I'm running some of these Bowler Fox EV50s. It's a 7018 electrode. I'm going to be running about 115 amps on the old ESOB 285 IC DC reverse polarity. I'm going to go ahead, fire up on the bottom here on the run-on tab, move up into that weld joint and just run until I can't run anymore. I'm probably going to have to do a restart about midway, but that's not a problem. You know, we're testing our ability to be able to do restarts and welds. So, and then we'll finish that off. We'll get the root in there, and then we'll just start layering that, that bead sequence in there. One thing I do want to point out is we put this much effort into our test pieces. This is the same amount of effort, cleanliness, and base metal preparation we should be putting into all of our work, regardless of whether we're working in a shop or working in the field environment. Take a few extra minutes, clean it up, set yourself up for success. That's when all that stuff's going to get inspected. That's when it's the most critical. Everybody welds a little bit different on a test because they want to pass it, but then they kind of sandbag the base metal prep once they get out in the field because we don't have enough time to do things right in the field. But if you have enough time to rework a piece or cut a weld out and put it back in, you have enough time to do it right the first time. All right, so we got the first half of the root in. I'm getting ready to make my tie-in, but just kind of wanted to walk you guys through this part. So as you noticed, I started off on the run-on tab, and I just went a little bit wide through here. Once again, I'm just building up weld metal so that I'm at the same height of my bead every time I go into this, because I don't want to start off kind of at a low spot and rise up to get back into it, because eventually this is going to be 1 inch tall. So I'm just building up a base down here of weld metal. That's all that run-on and run-off tabs are for. Just going up through here, just a slow, steady stringer. I'm just trying to hit side to side and just really dig into the bevels of each plate, as well as tie into that backing strip. Everything came out really good. I'm cleaning up with this this little Weiler toothbrush here because I want to get all the way into that groove. The best time to clean this stuff is right after you get done welding. Go ahead immediately and start cleaning it. That slag's going to come off a lot easier while the piece is hot. So if we wait in between passes to let the plate kind of cool down a little bit more to where it's manageable, not necessarily on the root or the hot pass, but the subsequent pass we're going to be putting in here. We want to make sure we do all our cleaning immediately after the welding. This stuff can't be too clean. However, if we start trapping slag in there and saying, I'm going to burn it out, I'll just turn it up 5, that's not really going to be a good method for you. That slag, you're just going to cover it up. You won't be able to see it until we go ahead and do a side bend, and then it's going to show up plain as day and then most likely rip. So we'll go ahead and perform the tie-in. What I typically like to do is just 2 hands, kind of wrap that up just like that, scratch about 3/8 above that crater, drop back into it, and then slowly start moving my left hand out of the way and just pick up like I never stopped with the rod. Try to maintain that nice uniform bead profile and not get any cold lap on that tie-in. So with this, I'm just really focusing on the side of those bevels. I want to break that down, make sure all this gets tied in and becomes solid weld metal. With the typical root and face bend, we're only testing one or the other. But with the side bends, we're testing everything: the root, the fill, hot pass, cap, everything that goes along with it. Now you'll see I just made it through the entire test plate, but I'm going to keep going all the way up through here on these runoff tabs up top here, because I want to build some elevation for once I start laying that cap. And we're done. Got one little booger here, but I should be able to flatten it back out once I go ahead and put in my hot pass. Now, I call it a hot pass. I'm just going to run it immediately after I get it cleaned out. I'm really not going to adjust my amperage at all. All right, so with these rods right here, I'm just running about 115 amps. Last time I ran this test, I think I was somewhere in 110, 115. I believe these rods run recommended by Bowler from 100 to 140 amps. So as long as I stay within that range, it's still considered pre-qualified. Once I jump out of those ranges, if I went less than 100 with this specific rod or above 140 amps, now I need to actually write a procedure for it. But because I'm staying within the manufacturer's specs, we should be good here. I'm going to go ahead and clean this out and then run that next pass. It's just going to be a little bit wider stringer. I'm not running weaves on this, but it's going to be a wider stringer. And my goal is just to cover up that root pass. You shouldn't see any of it. After that point, I'm going to go ahead and putting my weld layers in there with stringers the rest of the way, all the way until we get to the cap. Once again, just trying to build up some weld metal here for all my next passes. Now we're actually into the weld test area. Same tech as same technique as the root. Just running a little bit wider. Still a stringer, not running a weave here. Remember, that first pass was only maybe about 5/16 wide because we had a 1/4 inch root opening. You really want to focus on the sides because that's where you're going to end up trapping slag. You don't want a high ropey bead profile in the middle. So I pay a lot of attention to the sides here. I want to try and avoid my stacking all my starts and stops in the same area. So right now I just passed over that first tie-in, and then this is where I'll perform my second tie-in. Alright, so with this, I'm going to let that slag cool down just a little bit because I don't want to put any tooling marks in there. I want everything to be solidified before I start chipping that slag. Like I said, I'm set myself up here for another tie-in. I don't want to stack all the tie-ins in the same area. With this test, you're going to have to do tie-ins. So tie-ins are something you should be practicing. Another thing I highly recommend before you get into test day, especially if you're using a different electrode than you're used to, we're speaking manufacturers and brands here, not changing from 7018 to another rod. But if we're using a different manufacturer, we're using a different machine than we're used to, or something out of the ordinary, we're testing in a different facility, grab a scrap piece of material, get your machine dialed in, and run a couple passes before you get into it. You don't want the first weld of the day to be a root pass on a test plate. Give yourself, stack the deck in your favor. Run a couple stringers on some, some 3/8 plate. You know, just run a couple rods in there, get used to it, get in the swing of things. Make sure you know how that machine's set up. You got your hot start, arc force exactly where you want it, amperage, ensure you're on the right polarity. The last thing you want to do is go into this and find out you don't have something set up correctly. So run a practice bead on there, make sure you're comfortable before you're going into the test. Again, I'm just raking the sides here. That's where you're more than likely going to trap slag. You want to make sure all that is pulled out. Again, we can't be too clean. I know I've said that a bunch of times, but it's because it's important. If I trap any slag, I mean, that's where it's going to rip. I've done hundreds of bend tests for people, and you can see it. You know, as soon as you open up that root or open that face and you get a little bit of slag coming out of it, it's because improper interpass cleaning, and somebody said, I'll just turn it up 5-10 amps and I'll burn it right out of there. Well, that's not happening there, Skippy, so keep it clean. Once I get past these, I'll probably switch over to a bigger wire brush because I'm going to have more surface area in here. But right now I'm kind of deep into that groove, so I'm going to use this little guy. A little bit more detailed cleaning. All right, let's go ahead and same technique, perform the tie-in. I'm going to start just above it, 3/8, strike it, get back down into that crater, and carry on like I never stopped. Now remember, heat rises, so we may have to pick up our travel speed the closer we get to the top to keep that bead nice and flat. Once again, I'm right through the testing area, and go up here and just, again, lay in some weld metal from my next passes. You don't have to go as far as I do, just do whatever's comfortable for you. Right now it's glowing red hot. I'm going to give it a couple seconds before I start chipping and banging on it. I want everything to be nice and solid. I don't want to reshape that weld in any way, shape, or form. Got my tie-in right here. Doesn't look like we have cold lap. It's not as pretty as I'd like it, but she'll work. This is where I start going through kind of analyzing my pass. So I'm laying the groundwork for my next pass in here. So I got a little high spot here, but it's not in the welding area. So like I said, heat rises. So once I get up here, I'm probably just going to pick up my speed a little bit, or maybe terminate right before this bump that I have. And then I'll still have that same bead height. Get you a little inspection light, because 9 times out of 10, wherever you're testing, they're just going to have poor lighting. So make sure you can see up in here. See, I've got a little bit of slag right here that I didn't catch under normal lighting. So I'm going to make sure all that stuff's cleaned out. I don't want to trap any slag in here. That's going to be, it's going to be the #1 killer. Same thing, I want to pay attention to my run on and run off tabs. Make sure I don't have any slag in there, because I can pull some of that stuff into the openings and the exit up here. Now, because I'm a right-handed person, my next pass that I'm going to be putting in here, I'm going to favor this left-hand side. I'm going to come across my body this way. So I'm just going to follow the toe of that hot pass that I just put in there, strike down here, and I'm going to use that toe as my center line. I'm going to whip over here to the left, whip over here to the right just a little bit. Remember, stringer's not a weave. That's just my preference. If you prefer to run weaves and it works for you, do you, man, or woman, whatever you're more comfortable with. Once that pass is done, I'm going to go ahead, chip it, clean it, and then I'm going to make another pass. So that's pass #4. I'm going to focus on that right-hand toe. I'm going to shift my body this way a little bit, because like I said, I'm right-handed, so I'm naturally going to point to the left a little bit. So by shifting my body, I can keep the center of the weld exactly where I want it. If I focus in on here on straight in, I'm probably not going to hit as far to the right as I'd like to. So just by taking a half step forward with my left foot, I'm going to position myself center of that weld that I'm performing, not center of the joint. And it should help it lay in there nice and easy. We'll do that. And then the pass after that's probably going to be 3 beads. The course after that will be 4 beads. The course after that will be 5 beads. So it all depends on you know, how you get your groove spacing set up from the jump. It's probably going to be about 20 to 30 passes I'm predicting in here. So I'm going to keep a running tally, find out exactly how many passes we put in here. Now, because of the tolerances we're allowed to have, I'd have to double check with the code book, but you can there's some tolerances built into this to where you can shrink it just a little bit or open it up a little bit, depending on if you're running D1.1 or D1.5. D1.5 is the bridge code. So make sure you check your tolerances. You should have a welding procedure specification because it's a pre-qualified process that you can refer back to if you're at a testing facility, or if you're doing this at your local hall. They should give you the parameters. And sometimes they have bead sequence listed in there, and some places say stringers only, no weaves, or it's left up to the welder. So make sure you pay attention to those details. All right, so right now I'm just gonna go ahead and I'm gonna start filling this piece up. I've kind of already explained the bead sequence. So we're gonna do a little camera magic and just speed through some of these. We're gonna keep track of the tally of how many beads we're actually putting in here. And then we're gonna stop and go back into regular speed once I get right before the I'm ready to go to cap. Because that's another critical spot in here. I want you all to be able to see that portion before I go into cap, and what's gonna determine when I go to cap. Now when I'm throwing these passes in here, one thing that I'm gonna pay attention to is my interpass temperature. You can keep track of this with a temple stick. So the crayon will actually, once it's 350 degrees or above, it's gonna melt. I wanna try, and this is personal preference again, I've noticed that when I get above 350 degrees and I try to put my passes in, especially in vertical, that puddle becomes a little bit too fluid for my liking. It's harder to control. And that's just simply because the base metal is just so damn hot. I want to try to keep it and maintain a good interpass temp to where I'm not losing control of that puddle. So the more welds I put in here, the hotter it's going to get. So I'll probably put 2 more passes in here. I'm going to let it cool for about 5 minutes. That should bring me back down below 350, and then I'll throw that next course in there. Usually if you get it below 350, you can run 3 or 4 passes and then you shouldn't have to worry about it. Good to go. All right, we're now at the section where we're gonna go ahead and put in the cap. So just to recap everything that we've done so far, the root, hot pass, and then all the intermediate passes. I went everything from left to right. Now if you're left-handed, you're probably gonna run everything right to left on the inside. What we wanna try to avoid is welding on the left side, welding on the right side, and then welding some up the middle. You wanna try to keep your sequence the same every layer that we're putting in. Also, I had a couple low spots in here, so I just ran a couple short stringers to bring this back up to where the rest of the profile is, because you'll notice when you start running these things, it'll be a little bit lower down here and a little bit higher up here, and that's probably because we change technique or travel speed as we're going through. So I just fired up and ran a couple short ones over here, brought everything back up to profile, and then continued my sequence right over that. And you'll see when we cut all this stuff apart, this whole internal section is just going to be solid weld metal if we did it right. We shouldn't have any porosity, shouldn't have any slag inclusions. So because this is going to take a significantly long amount of time to do this test plate, you don't want to go grab all your 20, 30 rods at one time. I only grab like 4 or 5 rods at a time. I'll put a layer in, and then the next layer that I go to put in, I'll go grab another small handful of rods. I don't want to leave them out here soaking up hydrogen. So I just get what I need as I need it. They're gonna burn a lot better when you pull them right out of the rod oven versus if they've been sitting out on the desk or the bench for a while. So I'm gonna go ahead and grab a couple more rods. We'll run this first pass in real time, and then we'll probably fast forward through the rest of them because not much is gonna change as far as technique. What I like to do is just kind of use what's remaining of the top edge of that bevel as the center line of my pass, and come over just past that corner, that edge, about 1/8 of an inch, and just completely decimate it, right? That's the center line of my weld, is the edge of that plate. So that way I'm guaranteed to get a good tie-in to the top side of this plate. I had to do a stop and start right here. Oh well, no big deal. Once again, practice your restarts. And then, you know, don't think of it as, oh, I only have to go about 1/4 of an inch, you know, so don't try and force it and burn your knuckles going in there. That's what we got this runoff tab for. So fire it up, get that last 1/4 inch, and then carry it on the rest of that 1 inch pass. So we got a nice smooth tie-in right here. So now I'm just gonna take that rod that, what's left of that tie-in, and I'm gonna go ahead and start back down here, and my restart is gonna be somewhere else. I don't wanna stack all my starts and stops right across in the same area. I'm going to stagger them out, and an easy way to do that is just start with a shorter rod, and then I'll just keep going through doing restarts and starting off with different lengths of rods until I get all the way over to this side. Again, on this right hand side over here, my objective is to take that corner completely out and use that as the center line of my last pass, very similar to the first one. So I'm just going to maintain this same work angle, travel speed over here, and tie into pass number 1, and just make sure it's above flush, no higher than 3/16 of an inch for my cap. I'm anticipating probably 7 to 8 beads across here, so time's a wasting. Let's get to it. All All right, so we went ahead and got the cap on it. I'm gonna go ahead, it's been cooling probably about 10-15 minutes. We'll go ahead and take it down from the stand, throw it on the table, get some measurements on it. If everything's good, we'll go ahead and lay it out for cut. And I'll talk to you about exactly how we're gonna, where we're gonna pull the specimens from and how we're gonna prep that out. All right, so we went ahead and checked this thing, bottom to the top, everything looks good. Nothing is under flush, and the highest point is right at 3/16 of an inch. So we're good here. I'm gonna go ahead and lay everything out to do the cut marks, and I'll show you exactly how we're gonna do that. We're gonna find the center line of our plate. We're gonna measure north 1 inch and then south 1 inch from that center mark. And then it says the side bend specimen. So we have to figure out the thickness of the side bend specimen, which for all these is going to be 3/8 thickness. We're gonna use a saw to cut these, so we're not worried about the thermal cutting. We're just gonna cut them with a saw. We're gonna cut the 3/8 specimens out, grind the face flush, take off the backing strip, make sure that's flush, radius the corners, a maximum of an 1/8 inch, so I'll probably stay under that. I like to stay a little bit under, so I don't go over that 1/8 inch allowable maximum. So we'll go ahead and pull the two 3/8 specimens out of here, get it all prepped up, and send it to the bender. All right, so we have our pieces prepped. So this is the 1 inch, and this way we are 3/8 on both samples. So the way a side bend works is opposite of root face. So that's gonna actually, we'll be able to see the root, all the inner passes, and the cover pass. Well, not the cover because that's been ground off, but you'll see that weld this way. So we're gonna go ahead, put them in here, bend them. We have to bend 2 of them. Doesn't matter which way's up, which way's down, because they're both side bends. Oh, she's clean. Okay, nothing on the side walls. All the passes, root, inner passes, all the way up to the face of the weld. First one's a go. Let's go ahead and do pass number 2. You can do side bends? Like, yeah, man, calm down. So once again, no indications. Side wall, side wall. We're good. All right, ladies and gents, this concludes the D1.1, D1.5 1 inch 3G test. I want to give a big shout out to Stephen Marshall for sending us the plates. I hope that helped as far as bead sequence, how you get it all prepped up, the side bend process. Hopefully you guys have a good understanding of that. As always, if you have any questions, comments, or concerns, feel free to drop them down in the comments section. Don't forget to like and subscribe. If you guys have any videos you'd like to see, you don't necessarily have to send us material, but if you have a video, go ahead and submit it through the Weld.com website, or maybe just drop it down in the comment section. It's easier that way. Thanks again. Till next time, make every weld better than your last.